Kia ora koutou, Reese from QuickSense here, and today we're looking at area and volume of similar shapes. Now in this, the scale factor, so what we are reducing each of the sides by, is half. So this was 4, well it's now going to be shrunk down to 2. And so what we're asking is, what is it going to be, what's the surface area going to be with respect to the new shrunk cuboid? To do this, we're actually going to not pay attention to the numbers, right? We're going to think instead more generally. So what's the surface area of the original cuboid, the one we have at the top? Well, it's 2 lots of the length and the width. So if we think of this 12 here as the length, we've got the width here and then the depth here. Doesn't really matter, right, as long as we're consistent. So we've got the length and the width, and then we have 2 lots of the length and the depth, and 2 lots of the depth and the width. Right, so that gives me my 6 faces of this cuboid. What I'm going to do now is think about what happens if we decrease or we scale down each of these sides by a half. So my new surface area, right, it's still 2 lots of half, right, 0.5, half of the length times half of the width, half of the length times half of the depth, plus 2 lots of half the depth times half of the width. All right, we can simplify that a little bit. Half times a half is a quarter. Well, that's an S, not a 2. So that's a quarter length times width. Same here. And now because I have this common factor here, this quarter, I'm going to factor that out. Right? This is not a complete factorization, but hopefully you'll see what I'm doing. If I divide each of these by a quarter, I'm left with this here, which is what I began with. Right, so if my scale factor, k, is equal to a half, then the surface area, right, which is k squared, or something times something, well, that's going to be equal to half squared, or a quarter. And what we've shown is that this is true. To answer this question completely, right, now I know what's my new shape going to be. I can simply do, right, surface area of the new is going to be a quarter of 2 times the length, which is 12, times the width, which is 2, plus 2 times 12 times 4, plus 2 times 4 times 2. Ooh. All right, I'm going to get my calculator out for this, just in case I make some mistakes. All right, so we got a quarter of 160, which is equal to 40 centimeters squared. In this next question, we're dealing with volume. So whereas before, k was turned into k squared for surface area, we're now looking at k cubed for volume. So what's k here? Well, it begins with an increase of 10%. So we're scaling by 1.10, which means that k squared, or k cubed, is going to be whatever this is. So 1.1 to the power of 3, 1.331. So why is that important? Well, my new volume, right, so if I have volume 0 equal to 100 centimeters cubed, volume 1 is 100 times my new scale factor, which is 1.331, which is equal to 133.10 centimeters cubed. So now I'm scaling this down, right? So I'm going to have 0 point something. Well, what does that look like? Well, the new scale, the new volume, is equal to V1 times some scale factor cubed. Okay, so my new volume is 97.0299. My old volume, 133.10, and then K cubed. So K cubed is going to be equal to 97.0299 divided by 133.10. Okay. .729. Now I'm going to cube root that to get whatever K is. So find the cube root. I get 0.9. So what's the percentage of reduction? Well, either 90%, right? We're either doing 90% of the previous, or a reduction of 10%. This is a little bit ambiguous, but they both mean the same thing. If I'm doing 90% of the previous, then I'm minusing 10% of whatever that was.